Okay, last question. We're told here the drug Prevnar is a vaccine meant to prevent meningitis. It also helps to control ear infections. Okay, it is typically administered to infants. In clinical trials, the vaccine was administered to 710 randomly chosen infants between 12 and 15 months of age. Geez, they're toddlers, not infants. Of the 710 infants, 125 of them experienced a loss of appetite. Okay, now we are asked to obtain a point estimate for the proportion. Keyword proportion. So what do we know up here? We know 710 infants were in this study and 125 of them experienced loss of appetite. So the 125 over to 710 is going to be our point estimate. All right, we'll look at that in a second. Then we're asked to verify that the requirements for constructing the confidence interval are satisfied. Okay, so first of all, in answering the first part of that question, there's my sample proportion, and it becomes my point estimate. And okay, that works out to 17.6% of my sampled children experienced, whatever it was, loss of appetite. And what are the requirements? Well, the requirements are the same as, I don't know, we looked at up above. We assume that 710 infants were chosen randomly and independently from the population of all 12 to 15-month-old kids, and that 710 does not constitute more than 10% of all infants in this age range, which would be true. We also have to prove the success-failure condition, so we want the number of successes. This is the number of kids in our sample who experience, what is it we're looking at? Loss of appetite is 125, and the failures are this, and that's going to be 125 minus the 710 should work out to the 585. So both of these numbers are greater than 10, so we're good to go. All right, next thing says, obtain a 99% confidence interval using Minitab, and up above here and see, we got to do it by hand as well. So, all right, here it is by hand. Confidence interval on our proportion. We take our sample proportion p hat, that was worked out to be 0.176, plus or minus. Now, what do we want? Let's scroll back up here. We wanted a 99% level of confidence. The z-score that corresponds to that is 2.576. It will always be 2.576. And we plug in our p hat, 1 minus p hat, over our sample size, take the square root of that mess and multiply it by this. We end up with this, which if I take 1.76 plus and minus, this is the interval I get. Okay, so what can I say out of this interval? I could conclude, hang on, that I am 99% confident that somewhere between 13.9 and 21.3% of all infants between the ages of 12 to 15 months who were administered Prevnar will experience some loss of appetite. Okay, so that's what we get out of the confidence interval. So we've just answered parts A to E. Oh yes, and we got to go to Minitab to see if Minitab agrees with us, which we should always do because that's one way to check our math. All right, hang on now. Let me get this over here. So, stat, basic statistics, we are looking at a proportion. One proportion, we have summarized data. We know that, what was it? It was 125 of the 710 infants. And we wanted a 99% level of confidence, not equal to, and change this so that it reads normal approximation so you get the same answer as hand calculation. All right, there it is, and I can copy that. And I'm going to paste that back in my Word file, and we'll have a look now. Okay, so in my Word file, there's my interval, 0.139, and Minitab gives me the same thing, 139, 2.21. 2.8, which I've rounded off to 213. All right, so we've answered this question. Okay, we've got the confidence interval. Now we're asked, is there sufficient evidence to conclude that the proportion of infants who receive Prevnar and experience loss of appetite is different from 0.135, which is the proportion of children who experienced a loss of appetite with competing medications, and we're asked to figure this out at a 1% level of significance. We're asked to perform an appropriate test of hypothesis to answer this question, and then we're asked, does our answer in E, which is my confidence interval, agree with the results I get from my test of hypothesis? Okay, so we want a test of hypothesis. Now what are we looking for? We want to know whether the kids who are on Prevnar and experience loss of appetite is different from 0.135, which is the proportion of kids who've been given other types of medication, I guess for meningitis or ear infections or whatever this is. Okay, I need to specify a null hypothesis. Somebody's just turned out the lights here now, so this could be a challenge. Okay, first of all, remember your null hypothesis is one of, alright, I got the lights back on, so now I can continue. Okay, our null hypothesis is that the proportion of kids on Prevnar is, we wanted to know, is it different from kids on similar medications? Or actually, we wanted to know, is it different? Okay, our null hypothesis is going to be that it's the same. So same as other medications. We want to know, really, is it different? And of course, if it's different, I'm not being asked, is it higher, is it lower? I just want to know, is it not equal to 0.135? So this will make it different from other meds of a similar type. Now, we were asked to do what? We were asked to perform this test at a 1% level of significance. So 0.01 is what we're comparing our p-value to. And I got to calculate my test statistic. Now we're talking about a proportion. The test statistic is going to be a z. And that test statistic, hold on, is calculated using this formula right here. Okay, let's get rid of that. Okay, so my test statistic says z is equal to my sample proportion, which I worked out up above to be 0.176. I am comparing the sample to the proportion that's in my statement of hypothesis, 0.135. And be really careful here, because if you're not paying attention, you're going to get this screwed up. We want to divide by the square root of the proportion that's in the statement of claim, which is 0.135. So don't go sticking in the 0.176 here. All right, 0.135 times 1 minus the 0.135 gives me the 865 divided by my sample size, and I get a test statistic of 3.2. Because this is a two-tailed test, my p-value is going to represent, hang on now, I got it here and then I'll show it to you in Minitab. Oops, wrong one. Try that again. Yep. Okay, there's my p-value. So the area to the right of 3.2 is this. Because this is a two-tailed test, I need to multiply it by 2. And that 0.00137 approximately is my p-value. Now, if I go to Minitab and get this, so we've worked out a test statistic of 3.20, and without having to bother going with tables, come in here, standard normal distribution, whoops, I give it the x is my z-score, 3.20, and this is positive, so I'm going to want the right tail. Oh, sorry, I want both tails, sorry for this one. Right, and so my p-value is actually the sum of both of these values, and that is what is showing in our solutions. And I'm going to copy that graph over here so I have it. Hold on a minute now while I get this formatted. Okay, yada yada yada. Alright, now coming back over here. Alright, I got this. Now, where am I going with this? Okay, I got my test of hypothesis. Got my hypothesis, calculated my test statistic, figured out my p-value. This graphic just illustrates the p-value. Now, I should do this in Minitab as well, just so I can see how Minitab is going to work with this. So, back to Minitab. And coming back into basic statistics, one proportion. Now I already did this for the confidence interval, so my stuff is in here, my information. But this time I want to perform the test of hypothesis. I want to know, is the proportion equal to 0.135 versus not equal to? And it doesn't matter about my confidence level here because that does not affect my p-value. You should have normal approximation turned on. Say OK, and alrighty, if I copy that and bring this into my Word file, then we should see that what we get by hand, there's my test statistic of 3.0. Down here, Minitab tells me my z-score, my z-value is 3.20, sorry. My p-value I've worked out to be 0.00137. Minitab rounds it off to 3 places after the decimal, so here it is at 0.001. Okay, so now for the conclusion. What does this stuff mean? Our p-value was 0.001. Well, you can use that if you like, or you can use the one that we actually calculated, which is better. Alright, is that sucker less than or possibly equal to, what are we doing? We're doing this at a 0.01. 0.01. So, is this baby less than or possibly equal to 0.01? Well, alright, 0.00137 is definitely smaller than 0.01. The answer is yes. Anytime the answer to this question is yes, you're going to reject your null hypothesis. Okay, I'm rejecting the null. My God, they've turned out the lights again. Okay, I'm rejecting the null hypothesis. What is my null hypothesis? That the proportion is the proportion of youngsters who experience, God, what was this? Loss of appetite is the same as those on some other similar type of medication versus that it's not the same. I am rejecting this statement. I am concluding the proportion is different. So if I come back in here now and I write up my what have I got gone here? Hang on. Somebody's out here playing with the lights, driving me crazy. Okay, so what can I say? Results of a one proportion test. Actually, yeah, one proportion test. One proportion. That's what Minitab says up here. I give it the test statistic. Oops, I got that wrong, don't I? Test statistic is, I must have copied this from somewhere else, 3.20 with a p-value of 0.001. Shows that the proportion in the sample, which was 176 and equals 710, is significantly different from the 0.135. Or the other way I could say this is that it's not the same as the 0.135, which was the proportion of kids who experienced loss of appetite on similar medications. See? Statistics is not about numbers. Statistics is all about words. All right, I think that is it for this.